Hello class, welcome to lesson 2.6, which is all about ratios and proportions. By the end of this lesson, you should be able to compare ratios and solve proportions. So let's start with some vocabulary. Remember, a ratio is a comparison of two numbers by division. If you look, you can see a couple of different ways to write a ratio. You can write x to y, you can write xy. This is probably the least common, okay? And then this is the same as x over y. That is a fraction bar, okay? So these two things are the same. Those are three different ways that you can write ratios. All right, a proportion is an equation stating that two ratios are equal. Okay, so having two ratios that are equal. Means are the middle terms of the proportion, and extremes are the first and last terms of the proportion. So if I say 3 to 4 and let's do 5 to 7, my means would be the middle terms, and my extremes would be the first and last. Okay? A rate is a ratio of two measurements having different units of measure. A unit rate is a rate that tells how many of one item is being compared to one of another item. Okay, so that'd be saying I purchased, let's say, 10 books for $50. What was the unit rate? The unit rate, so you'd figure out how much should one of those books cost instead of 10. Alright, and then we have a scale. A scale is used when making a model of something that is too large or too small to be convenient at actual size. And a scale model is a 3D reproduction. Scale model is a 3D reproduction of an item that has been reduced or enlarged in size proportionally. So scale models, some examples of when scales are used. Well, one, a scale is used most commonly on a map. So if you look at a map of the world, sometimes you can, if you have a globe, you can reach from one continent to another, and obviously there's more distance between the two continents than your one hand. So a scale is used to show that distance, okay? And a scale model, a 3D reproduction, a globe would be an example of that. Or if you see model trains, model cars, models of buildings before they're built, okay? So there are a lot of real-world examples with these. Let's jump into our first example. We want to determine whether each pair of ratios are equivalent ratios. Write yes or no. Okay, so if we look at this top one right here, we have 9 over 11, and we have 81 over 99. 9 11ths and 81 99ths. So are they equivalent? So I look at 9 over 11 and I think, okay, that's as reduced down as it can be. Is 81 over 99 as reduced as it can be? No, because if I think about it, this has a common factor of 9. So if I divide 81 by 9, I have 9, and 99 divided by 9 is 11. So these two ratios are equivalent. So you have to make sure that they're written in simplest form, or maybe you looked at these and you said, well, if I were just to multiply by 9, I would end up at this one, so you knew they were equal. That's fine too. Two different approaches, but you need to say yes, and you need to show work to show me that you know why they're equivalent, okay? So showing that this is multiplied by 9, or write that this is divided by 9, either way. Alright, 4/3 and 6/8. Is there any way that these two are equivalent? Because if we look, 4 going to 6, or 3 going to 8, 3 doesn't really go to 8. So I'm going to go ahead and say, no, these are not equivalent. And one way to check, you could always reduce this. 2 goes into both of these numbers. 2 goes into 6 3 times. And 2 goes into 8 4 times. So you're left with 3/4, which is not equal to 4/3. Okay? Go ahead and try this one on your own, see how you do. Hopefully for this first one you said they are not equivalent ratios. Let's take a look at the second example. We have used cross products to determine whether each pair of ratios forms a proportion. So what a cross product is when you multiply on the diagonals, okay? So we're going to multiply on the diagonals. So starting with, I have 0.2 times 0.9, and we want, in order to determine if they are a proportion, remember you need an equal sign, and now you do 1.8 times 1, okay? 2 times 9 is 18, and I have 2 numbers behind the decimal point, so I need 2 numbers behind my decimal point. So I have 0.18 equals, and then 1.8 times 1 is just 1.8. Is that true? Nope. So we are going to say that this does not form a proportion. So let's look at part B now. We have 15/36 and 35/42. We want to determine, are these two ratios, do they form a proportion? Are they equal to each other? So let's start by looking at them, and we have, we do our cross products again to see if they are equal. So that means we have 15 times 42. Does that equal 36 times 35? Okay, so if we do 15 times 42, we end up with 630. And if we do 36 times 35, we end up with 1,260. Are those two equal? No, so we'd say not a proportion. Alright, the next one gives you a chance to try it on your own. See if you can use cross products to determine whether the pair of ratios forms a proportion. Hopefully you guys ended up with the same number with your cross products, which means the ratios do form a proportion. Alright, example 3. We want to solve each proportion. If necessary, round to the nearest hundredth. Remember, when we're dealing with hundredths, that is the second decimal place. The first one is tenths, and then the second one is hundredths. So part A, we have r over 8 equals 25 over 40. Okay, we want to solve the proportion. We're going to do the same thing. We are going to do cross products, okay? So the way that we do that, we have r, my smartboard's being a little slow, sorry. I'm going to try that again. We have r over 8, so we're going to do 40 times r equals, and then we have 25 times 8. So 40r equals what? What's 25 times 8? That gives us 200. Alright, and if we tee it up, we want r by itself, so we're going to divide both sides by 40. We have r equals, what's 200 divided by 40? They both have a 0 in common. What's 20 divided by 4? 5, and then we still have 1 0, so 50. R equals 50. Okay, that's how you can solve these proportions when you have a variable involved. Let's try it a little step further with difficulty. If you notice on the left-hand side of part B, we have x plus 4 over 5. So our variable isn't completely by itself yet. Let's rewrite it. We have 8 times, and then remember, it has to multiply both, okay? So 8 times x plus 4. And since we don't normally write the multiplication symbol when there is parentheses involved, okay? When there's parentheses involved, I'm going to get rid of that, and then I have 5 times 3. If I simplify this, I should distribute. So that means I have 8x plus 32 equals 15. And now it's just like solving equations. Remember, you do PEMDAS backwards. So that means I'm going to take care of the addition and subtraction first. So I'm going to subtract 32. So now I have 8x equals, and then 15 minus 32 gives me negative 17. My next step after I tee it up, I need x to be by itself, so I'm going to divide both sides by 8. And now I have x equals negative 17 eighths, or you could say about negative 2.125. Okay? Either or is a perfectly fine answer, but just make sure the biggest step is to set it up correctly and then distribute correctly. Remember to distribute to everything. All right. Try this one on your own, see how you do. Okay, hopefully you ended up with 16 as an answer. If not, be sure to ask for some help. That goes for previous examples as well. All right, let's take a look at example 4. We're talking about bicycles now. The gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. Suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have to crank the pedals during the trip? Okay, so the way that we need to go about setting this up, we know that for every 8 turns of the pedals, the wheel turns 5 times. Okay, so I'm going to say 8 pedals is 5 turns, right? That's our ratio. That's another way to write it. You put the first number on top. All right, and then we'd say equals. And then what other information do we know? We know that on this trip, the wheel turns about 2,435 times. Okay, so the wheel is 2,435 turns. And we want to know how many pedals does it have to go. So we don't know what that number is, so I'm just going to put P there. All right, and just to rewrite it without the labels so it's a little easier to work with, I now have something that looks very familiar. Okay, again, we're going to do our cross products to solve. So we have 8 times 2,435 equals 5 times P. So if we simplify that, sorry, not teeing it up yet, 8 times 2,435 is 19,480 equals, and then 5P. How do we get P by itself? We divide both sides by 5. We're left with P. That was terrible, P. There we go. Equals, and that is 3,896. So our answer would end up being 3,896 pedal turns. Make sure you label it, because if you don't label it, I don't know if you're talking about the wheel turns, I don't know if you're talking about the pedal turns. So labels are super important, okay? Why don't you go ahead and try this one on your own? See how you do. Hopefully you ended up with an answer of 45 miles. If not, be sure to ask either myself or a friend for some help, and we'd be happy to help. Let's look at our last example together. In a road atlas, if you don't know what a road atlas is, that means it is basically a book of maps, okay? People used to keep them in their car a lot, especially before GPS and smartphones, okay? So, road atlas, you may or may not have one. The scale for the map of Connecticut is 5 inches equals 41 miles. What is the distance in miles represented by 2.5 inches on the map? Okay, so highlighting some important information. I know 5 inches equals 41 miles. So 5 inches is 41 miles. And then we want to know what is the distance in miles represented by 2.5 inches. So 2.5 inches, and we want to know the miles. Okay? One important thing that I don't think I really pointed out when we did the bicycle option, notice that inches are on top here, so that means inches have to be on top in the other side of the equal sign, on the other side of the equal sign. Same with the miles. Miles are on bottom on the left, so they're on the bottom on the right. Okay. Now, we want to cross multiply and divide. I'm going to simplify or rewrite it without my labels just to determine what my answer is, okay? And actually, instead of miles, I'm just going to use x for now and then label at the end. Okay, so let's cross multiply and see how we do. 5 times x is just 5x, and then we have 41 times 2.5. So we have 5x equals, and then 41 times 2.5 gives us 102.5. Now, if we tee it up to get x by itself, I know I have to divide because we were multiplying. So now I have x equals, and then 102.5 divided by 5 is 20.5. I'm not quite done yet. My last step is to write it with its label. So 20.5 miles. If you just put MI instead of writing out miles, that's fine. Make sure you don't just do an M though, because that stands for meters. Alright, try this last example on your own and see how you do. Hopefully you ended up with about 2,114 miles. If not, be sure to ask for help. I'd be more than happy to help you. And that goes for any questions that you have on this entire lesson. Just be sure to let me know and ask for help. Alright, I hope you guys have a great night, and I'll see you tomorrow.